Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So here in this video we discuss the chapter the differentiation. So many of the friends they have requested to start the differentiation as well as the integration. Now first thing is we just go for the differentiation. So in this differentiation chapter what we today will study about. So what is the differentiation? So first thing we'll just study. So what is differentiation? So what is the meaning of this? So next thing is we'll go for the how we can able to represent this differentiation, that is a representation. And next we'll study what are the different types of functions. And the next thing we'll go for the what are the some few list of formulas. Okay, I'll go for the formulas here. Now basically this differentiation is also called as a derivative. So derivative means, for example, if I take any one function, it may be there are basically 5 types of functions are there. We'll just come later here when it comes for the function, different types of functions. Now if I take any one of the function here, so what happens? So once if I change the value of that the value of that function, so for example, if I take suppose y is equal to like a 3x square plus 4x plus 5. So you just see that, so this is one of the algebraic functions. Now in this function, so which indicates that, so this y is a function of x. So means what? So when I change the value of x, in this case you can just see the changes in the value of y. So for example, if I take x is equal to 1, so what happens? You just substitute the value of x in this equation, like in the function. So it becomes 3 into 1 square plus 4 into 1 plus 5. So which gives 3 plus 4 plus 5. So which gives again 9, 12. So means what? This y is called y is equal to, it said 12 here. So means what? This y is a function of 12 for y is a function of x. For example, if I take this x as 2, the next condition, if I take x is equal to 2, so what will be the value of y? So it becomes, I can represent here y of 2, because I'll take here y of 1, because it's nothing but, so we are just substituting the value of x as 1 and 2. Now what happens to this y value now? We just place the value that is in place of x, I'll just substitute the value as 2. So it becomes 2 square, that's nothing but a 4 into 3 is 12. Plus 4 into 2 is 8 plus 5. So it becomes, it's at 25, that is y of 2. So means what? Ultimately, so when I change the value of this x here, so I can have a changes in the value of y. So means what? So this is nothing but something like a derivative here. Okay. So now this differentiation is also called as a derivative of any of the function here. For example, just to understanding here, so sugarcane I'll take. So sugarcane is nothing but it's something like, assume it's a product here, or you can take this as some function. So from that sugarcane, what I'm getting, I can get like sugar here. So this sugar is nothing but it's a derivative of that particular sugarcane. So means what? We can have something like derivative of any given function. We have to find out the derivative of this one. Okay. Now let us move on to so this gives somewhat like a differentiation here. Now how we can able to represent this differentiation? So differentiation means, again, if you just take any function like y is equal to 3x cube plus 4x or something. Okay. Now if I take the function y is equal to 3x cube plus 4x, actually this is a given function here. I need to find the derivative of this function y here. So means what? I need to differentiate this given equation or function with respect to x here. So that can be represented by, so d by dx of y. So means what? This function I have to differentiate with respect to x. So means what? I can represent this as d by dx of y. Differentiate the function y with respect to x. So this how we can represent the derivative of any given function. We can represent like this also. If for example, so this y is given, if I directly take y dash is equal to, so this y dash is also indicates it's a derivative of this given function. Means what? After differentiating with respect to x, I can have some solution here, so that we can represent as y dash. It's nothing but a derivative of any given function. Or when we differentiate the given function with respect to x, once if the function is given in terms of x, if the y is equal to some, for example y is equal to, if he has given like t square plus t or plus 2, so then it becomes d by dt of y. It's nothing but what? Differentiate this function with respect to t, so that can be represented by dy dt of y. Okay, because we are differentiating this with respect to t. Okay, now this y dash is also indicates it's a derivative here. Again, sometimes they will be given the function of f of x is equal to some equation will be given like x square plus x plus 2. So this is also something like, this is a function of x is equal to some function is given x square plus x plus 2. Now I need to differentiate this equation or this function with respect to x. So means what? At the end what I am getting here in the left hand side is f dash of x. So this f dash of x is equal to some solution I will get here. Okay. Now this f dash of x is also represents the derivative of a given function. So that we can represent this as either in the form of y dash. Once if the function is given, that is a y function is given, either we can represent with the d by dx of y. Once if the function is given in terms of x, again we can have some f dash of x. In these three ways we can just represent the given differentiation for any of the function here. So the thing is what? It should be, the function should be in terms of x. If the function is given in terms of t or any other variables, we have to represent the same here like t, x, z or etc. Now what are the functions here? So functions means there are lot of functions are there, so on which the problems we have to solve here. So if I take the functions, so basically we will be having a 5 types of functions here. So that can be represented, just for understanding, just to remember here, I will just write here L, I, A, T, and the last one I can take this as E. Okay, these are the 5 types of functions. So L indicates it's nothing but it's a logarithmic function. For example, if I take y is equal to, I can represent with the f of x also. What I am giving here is, it's just I am giving a function in the form of x here, that is y is equal to function of x is equal to, so we are just talking about the logarithmic means I just take log of ax plus 2, like that we can have here. So now this is your logarithmic function, so that I have to represent here, this type of functions we called as the logarithmic functions. Again this is nothing but I indicates it's a inverse function here. So for that I'll take this y is equal to f of x is equal to, so inverse is nothing but I'll take like this sine inverse of like phi x. So this is our inverse function. So means what? This kind of functions are called as like inverse function here. Now we'll be having some, sorry, A indicates it's a algebraic function that can be represented by, so y is equal to f of x is equal to, means what? It's a function of x is equal to, so this algebraic means it's something like we'll be having some equation type like phi x square 4x plus 2, something the equations will be having here. You can just see this this is something like algebraic equation here. Now this is our third function. Now what is by t means, so this t indicates it's a something like trigonometric functions, we'll be having sin theta, cos theta, etc. lot of those things will be having. Okay, so this t indicates it's a trigonometric functions, so that I can have some sine of phi x plus 2, like that I can take here. So this type of functions are called as a sine or cos. You can take any trigonometric functions. So these are called as a trigonometric functions. The last one is, it's a exponential function. So I'll take, so that y is equal to function of x is equal to, you can take like e power 5 or 6x plus 2. So this is nothing but our exponential form of functions. So why we have to study means, because when we go for the numerical problem, okay, numericals, when we solve, so we'll be having only this kind of functions will be there. So we should have to know which kind of problem it is, so which kind of function it is. So just to know the basic concept here, I have given the function types of functions. Now let us move on to the last topic for the today's video, that is a list of functions here. So once if you know the list of functions, once if you know the basic formulas here, we can able to calculate, we can able to get the derivative of any given functions very easily. Only thing is what? So we should have to practice. So we should have to practice this list of formula here. So basically some 12 to 15 that is the formulas are there. So again we have studied the first that is the differentiation of the any given function by using the first principle. So but the first principle is something like, it's a quite lengthy process. Even if I give a small, okay, like a function here, so to get the solution here I need to go for 1 or 2 pages. So but by using the formula method we can able to get the like a derivative of a given functions very easily. Now we just move on to the some few list of formulas here, so that we can easily remember, and when it gives in the given in the problem, directly in place of that we can directly substitute that is the required derivatives here, like differentiation. For example, if I take, now this is our given f of x, like function of x, I need to derive, that is I need to differentiate with respect to x, so that I can take this as some f dash of x. Okay, that's nothing but it's a derivative of a given function. Now for example, if I take the constant c, so constant c is nothing but, okay, the value of that particular constant will not be changes. Okay, so means what? The derivative of any constant is almost, okay, always it will be a 0. For example, if I take y is equal to some 5, because here there is no x, so what is that here? If I find dy by dx, it will be a 0. So because there is no x term over here, okay, so such kind of the constant is given, so directly we have to substitute. It says that is a differentiation of that particular constant is 0. So we have to remember this. Now the next thing is, we'll move on to the differentiation of x to the power n here. Okay, now x to the power n is nothing but, if I give the differentiation of the x to the power n is, for example, if I take f of x is equal to x to the power n, now I need to differentiate this, differentiate with respect to x. So if I differentiate with respect to x, so I can take this as f dash of x is equal to, the solution is you just take this n to the front portion here, take the front side, that is you can just have a n here, and you can just write x as it is, but in the power you have to just take the n minus 1, you have to subtract 1 with the given power here. So this is the formula what we have to remember. So but actually this formula we have derived by using the first principle. So we need to have it, we need to remember this, x to the power n is equal to n into x to the power n minus 1. Okay, now we just move on to the differentiation of 1 over x. So these are basically some important formulas what we have to remember here. Now this 1 over x can be written as x to the power minus 1. Now again this is in terms, so this is in the form of something like x to the power n. So where n is nothing but minus 1. Okay, now by using the same formula we can just have the solution for this also. Now in place of 1, so solution is what? N into x to the power n minus 1, I have to substitute. Now n is nothing but our minus 1 is there, so x will be same, so n means again it will be a minus 1, this is minus 1, so here it's a minus x to the power minus 2 is there. So this power x to the power of minus 2, I can take it in the denominator, so that I'll take here minus 1 over x square. Okay, now finally we can conclude that the differentiation of this 1 over x is, I can take this as minus 1 over x square. But the thing is what, we no need to write all these steps here. When the function is given in the form of a 1 over x, directly we can write the derivative of differentiation of 1 over x is minus 1 over x square. Similarly, I am having a root x. I will take differentiation of root x, I can have it 1 over 2 root x. Again this also we have to go further by using the same formula. For example, so root x can be written as what, it is a x to the power half. So for this, where this is in the form of some x to the power n, I can have a formula is what, so it is n into x power n minus 1. So where n is nothing but a half here, so I will write here half x to the power half minus 1. So this become half into x to the power of minus half. So this minus is there, I can take it in the denominator. So that will be half into 1 over x to the power half. So this power half I can take it as 1 over 2 root x. So this is the derivative of this root x as 1 over 2 root x, but again we no need to go for this. Directly once if the function is given in the any problem like 1 over root x, directly we can write 1 over 2 root x. Okay, next we will move on to the differentiation of log x. So this is quite logarithmic function. Directly we can represent the differentiation of the log x is 1 over x. Similarly, we will be having some exponential function, that is a e power x is equal to the e power x itself. So this function will not be changes even after getting the differentiation with respect to x. So the last one I can take this as some a power x. This is also quite same as this one, but this is a completely different one. So differentiation of this a power x as, it's a power x into log x. So here we can have some base e also. So we no need to represent that also. Even if you represent, it's no issue. Now this is a basic formulas what we have to remember. So along with that, so we are having some trigonometric functions as well. Like we will be having trigonometric functions and some inverse functions are there. So but those two list of formulas we'll just study in the next video. So till then be with us, Mr. Math Academy.